Under graphical method, we have different sub-methods. An example of that is the parallelogram method. The parallelogram method is also known as the tail-to-tail method. It's called tail-to-tail because you are going to connect the tail of the first vector to the tail of the second vector. Basically, parallelogram method is used when there are two given vectors. Let's say for example here we have vector A, which is 10 Newton going to the east, and 5 Newton for B north of east. Let's say that north of east, let's add an angle for that. Let's say it's 30 degrees. So we have here our Cartesian plane. If you are going to analyze our given, you will learn that we need to use the first quadrant. Let's start graphing our given with vector A. So vector A is 10 Newton to the east. So from the origin, you're going to the east with 10 inches because we are going to assume that 1 Newton is equal to 1 inch. So from the origin, you just graph it through the x-axis. So this will be your A. That is 10 Newton. Then we have vector V, 5 Newton north of east 30 degrees. So first you have to identify the direction. We have north of east. It means from east going to the north, and that is 30 degrees in angle with 5 Newton as magnitude. In your ruler, you can use 5 inches for 5 Newton. So let's say for example, this is already 5 Newton, which is B, and then you place 30 degrees here. Our next step is forming our parallelogram. So how to form our parallelogram? Simply copy the given vectors. So first, let's copy the vector A. So this one is our vector A. We just copied it. So that's also 10 Newton. And then next, we copy vector V. That is 5 Newton. So we have now a parallelogram. Now how to get the resultant vector of these vectors? Okay, so from the origin, you are going to connect the head of your resultant force to the heads of the copied vectors. So this one would be your resultant vectors. If you're going to measure that using your ruler and protractor, you will get 14.6 inches, and that will be 10 degrees in angle. Therefore, the resultant vector for this will be 14.6 inches, 10 degrees north of east. Okay, so let's have our problem number 2 for parallelogram method. So if you are going to analyze our problem, you will learn that we will be needing the third quadrant of our Cartesian plane. So let's start graphing our given with vector A. So vector A is 5 Newton to the west. So it's west. It means you don't need an angle for that. So you just graph our vector A with the x-axis. So it will be like this, and it will be 5 Newton. That's your A. Now we have here B, which is 3 Newton west of south, 45 degrees. So from south going to the west, so that will be 45 degrees. So that will be 3 Newton, which is B. To form the parallelogram, you have to copy the given vectors. So let's start with A, copying A, and then copying B. We have now a parallelogram. So we can now get the resultant vector for this problem. So from the origin, going to the two heads of the copied vectors, that will be your resultant vector. So using your protractor and ruler, you have to measure the length of this resultant vector and the angle